Hi everyone, and welcome to MathSux. This video is going to help you pass Algebra 2. In this video we're going to go over rational exponents and radicals, first by looking at what rational exponents are and how they relate to radicals, then writing some rules based on what we find. Then we're going to try an example where we can apply all the rules we find. So all rational exponents are exponents with fractions in them, and the cool thing about them is that they can be written in radical form and vice versa. So you can write a radical as a rational exponent and the other way around too. So if we look at our first example, we have 4 to the 1/2 power. So this can actually be rewritten as radical 4, which of course is equal to 2. So if we wanted to write a rule to show this, we would say m raised to the 1/2 is equal to radical m. So if you look at our next rational exponent, we have 8 to the 1/3. So this is actually equal to the cubed root of 8. So here, there was kind of like a little 2 here, but you just don't see it. And here, we have a cubed root because of this 3 down here. And this is also equal to 2. And the cool thing about these questions are, if you ever forget a rule, you can always plug this into your calculator. So if we go 8 raised to the 1 divided by 3, we actually get 2 also. So you can always double check yourself for these kinds of problems. And if we want to write a rule for this, we would say m raised to the 1/3 power is equal to the cubed root of m. So our next question, we have 16 raised to the 3/2 power. So this now has a value in the numerator. So let's see how this will relate to our question here. So to rewrite this in radical form, we would say radical 16, right? Because we see that 2 in the denominator, so we know it's going to be a regular radical. And what we do now is we cube it. So this exponent in the numerator, this 3 in the numerator, that just acts like a regular exponent. So radical 16 is just 4. And then now we're raising this to the 3rd power, which is 64. So 4 cubed is 64. And let's write our rule on the other side here. If we have m raised to the 3/2 power, this is going to be equal to radical m cubed. So our next question looks a little different. We have 25 raised to the negative 1/2. So what happens here was actually kind of flip and make a fraction. So we put a 1 over this, and this now becomes 1 over 25 to the 1/2, which is then equal to 1 over radical 25, right? So we just wanted to make this positive by putting a 1 down here because this is negative. So, and then this becomes 1 over 5. So if we wanted to write a rule for this, we would say m raised to the negative 1/2 is equal to 1 over radical m. And now for our last example, to get our last rule, we have 8 raised to the negative 2/3. So again, we want to put this in the denominator, so this becomes positive. This becomes 1 over 8 to the 2/3, so this is positive down here. And then we can then convert this into 1 over the cubed root of 8 raised to the squared power. So, sorry, this is a little messy to see. So this is the cubed root of 8 we found before was 2 up here, and now we're just squaring this, so this is equal to 1/4. And our rule for this would be m raised to the negative 2/3 is equal to 1 over the cubed root of m squared. So just take a look at the next slide if you missed anything or if something was hard to read, and you could see all the examples we just went over and the rules that go with them. And now let's take all our rules and combine them with everything we just found into our harder example that says 2x raised to the 3/2 power over 16 to the 1/4 times x. So to solve this kind of a question, we're going to do the same thing we've been doing with our rules, just now it's a little more complicated looking. So what we first want to do is convert from rational exponents to radical form. So notice this 2 isn't raised to any power, so we're just going to leave that the same. And now we have this x raised to the 3/2 power. So based on our rules, we can say radical x cubed, right? Because this is in the denominator, so we know it's going to be a regular radical. And then we're just cubing it. And then this is over 16 to the 1/4, so that is the quad root of 16. And x, there's no exponent here, so this is just x. So now let's see if we can simplify this more, or actually in this case we're going to be expanding this. So we have 2, and then we have radical x to the 3rd power. So let's just write out what that means. So radical x times radical x times radical x, all over the quad root of 16. So the quad root of 16, you either might know that, or you could plug it into your calculator. It's just 2. And then we have this lone x here. So this next step, it might be a little tricky, but any radical times itself, so radical x times radical x is actually just x. It's just whatever's inside that radical, and that works for any number. Radical 5 times radical 5 is 5. Radical 10 times radical 10 is 10. So we have 2x, because we're multiplying these two guys, and then we're just left with another radical x here, all over 2x in the denominator. And notice we can just cancel these out nice and easily, and all we're left with is radical x as our answer, and that's our answer. So when looking at rational exponents, just remember to always convert them to radical form, and then try to simplify and expand or evaluate to get the answer. And when in doubt, if you forget how to do any of the rules, you can always check yourself with the calculator, which is really nice. So these are just a few examples on rational exponents. For more, check out the practice questions posted on MathSux.org. The link is in the description below. And if you enjoyed this video, please give it a like. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!